Hello again. As I said, I broke this chapter up into two segments. So this is the second part. And where I am going to start now is by going through the different types of psychoactive substances. So there are three main groups. There's actually more than this. These are just the three sort of classic groups of substances that we're going to discuss this semester. And I'm going to give you some examples of each from each category. So I'm going to start with the first group, which are the depressants. In general, depressants are any sort of drug that will reduce neural activity by slowing down the bodily functions. Basically, that means it slows down the central nervous system. And this would include substances like alcohol or opiates. So let's quickly talk a little bit about what these two might do. So alcohol affects your motor skills, your judgment, your memory. It might also increase aggressiveness while also reducing self-awareness. Overall, alcohol depresses the central nervous system by enhancing the effects of GABA. So if you remember way back in the semester, we talked about how GABA was an inhibitory neurotransmitter. Basically what alcohol does is it almost mimics GABA. It uses the same receptor that GABA does. This one would be one of those agonist ones. It acts on and uses the same receptor that GABA does. As you can see from the image that's here, alcohol, long-term use of alcohol is very bad, not just for your body itself, but actually the brain. You can see this is a woman who doesn't have alcoholism and hasn't used alcohol long-term, and then this is a woman who has, and you can just see the parts of her brain have basically just deteriorated from the long-term alcohol use. This woman has also developed something that's called Korsakoff syndrome, which leads to basically a loss of memory. And again, alcohol is just very dangerous for your body as well as your brain long term. But again, let's think about the body side effects. So it actually can destroy your liver over time. So your healthy liver should look sort of like this, nice and reddish, pinkish color. Again, we already talked about the importance of the liver for getting substances out of your body. And I'm not just talking about the illegal substances. Anything that you put into your body, the liver is probably going to help you break it down to get it back out of your body. So this would be even medications that you want to take, that you need to take to keep you alive. And it should be this kind of reddish color, maybe even be a little bit brown. But again, it's supposed to be rubbery. This is what makes it healthy. When it starts to become damaged, particularly by alcohol, it's going to become this yellowish color. We call it fatty liver, and that's because it actually kind of becomes greasy looking. It's got some fat that it's stored in it. At this point, the damage is reversible if you stop the drinking and if you take care of yourself and if you coordinate with your doctors to be put on a healthier diet and a healthier lifestyle. But if not, the liver itself will start to then die and get scarred, and it will become what we call cirrhotic. And this is what a cirrhotic liver looks like. At this point, the liver itself is no longer going to be able to heal itself, and it's actually not going to be able to then do what it's supposed to be doing, which is helping you break down other substances in your body. And at this point, you could even end up with liver failure, which would actually mean that your blood isn't getting filtered out and stuff isn't getting broken down. And it just leads to a whole host of other problems. So this is a very dangerous thing. And again, it's one of those things that, if you're young and you're healthy and you're looking at this going, yeah, I'm never going to have to worry about this. Well, you don't know that. And it's one of those things too. Alcohol doesn't care who you are. Anybody can develop an addiction to alcohol. And once you're there, it's not too far off to then start to develop some of these more long-term problems. The other class of depressants would be opiates. Opiates and their derivatives, which are what you probably actually know the name of, which would be morphine and heroin. Their job, again, is to depress neural activity. Morphine is probably used legally. You may have even had some if you've ever gone in and had to have maybe some kind of medical procedure done. Morphine is sometimes used for pain. It's also temporarily given in very small doses to help reduce anxiety as well. But the issue with these is they are very highly addictive. So morphine is the major active ingredient that's actually in opium. So you can actually take opium, the opium plant itself, and it was actually isolated way back. We've known about this for a long time. And what we actually found, hey, we don't have to just take the opium plant anymore. We can actually just isolate this morphine thing. And it's a lot more potent, so we can actually use less of it. We can actually artificially make it, and then that's actually a much better idea. And then what we found is that we could actually chemically alter morphine and make it into something called heroin. That was discovered in the late 1800s. But what we found is that heroin was even more likely to cause addiction. So you're actually even more likely to become addicted to heroin. So how these two work, because they don't work in the same way that alcohol does. Remember, alcohol worked by basically mimicking GABA. These ones mimic your natural endorphins. So you have natural chemicals in your brain that basically act like morphine does. They act like your brain's own painkillers, your brain's own opiates. So you have a natural painkiller relief system in your brain. So whenever you're experiencing some kind of pain or stress, your body will release its own set of endorphins. And so what happens when somebody takes opium or morphine or heroin or any of these various derivatives is that it acts on the same receptors that your natural endorphins would. And so that's why you experience the sensation of pain relief, or some people may even say it kind of feels like a high. Now, this has also been in the news a lot lately, right? You may have even heard them saying something like opiate crisis or opiate thing that we're in, and it's true, right? There's been a lot of problems with people buying and selling opiate derivatives on the black market and people overdosing, because it's very easy to overdose on substances that are not sold by a pharmacist or by someone that can tell you exactly how much is in it, that you know it's a pure substance, so you know exactly how much you need to use based on your body weight. And there's a lot stronger stuff out there. So again, morphine was already stronger than opium, but we use morphine as the standard. All right, so basically what we do is we take morphine and all the various chemical derivatives, and we give morphine a score of 1. And we say morphine is kind of the standard strength of the opiates, and we're going to give it a score of 1. All right, so we give it a potency score of 1. Then we have all the other kinds of painkillers, and you may have heard of some of these other ones like hydrocodone or codeine, oxycodone, right? You may have heard of some of these. Fentanyl is the one that's been so lethal. Right, but again, we gave morphine the score of 1. And we said, here's how potent some of these others are. And so here's why heroin was such a problem for a while, because it was like double the strength of morphine, right? But here's why people are so scared and why fentanyl has been such a problem. Again, keep in mind, heroin was just double the strength of morphine. Look at fentanyl, 100 times as strong as morphine. This is why it is so dangerous and it's been causing so much problems. So again, if you're a drug dealer, yeah, it's great because you can put just a very tiny amount, you can make a huge profit, blah, 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 blah. But again, we're not in the business of being drug dealers here. We are psychologists. We are coming at this from the perspective of how can we keep people safe and get them to make safe choices? Well, again, having something like this on the streets is a very dangerous situation to be in because, again, it's very hard for somebody who's probably already not making good choices anyway to then give themselves a safe and effective dose of something like this if they're going to be using an illegal substance. So this is why we're seeing so many overdoses, because there's a lot of drugs out there that aren't necessarily clean and pure. They might be mixed with something like this that is super strong, and again, it's very easy to overdose. So those are the depressants. Kind of the exact opposite effect on the nervous system would be the stimulants. Stimulants are drugs that excite or speed up the activity of the nervous system. Again, they're going to increase communication between between neurons by giving and producing more action potentials. There's a lot of different kinds of stimulants. I'm going to talk about 5 different ones. The first 2 are legal, at least depending on your age. Caffeine's legal probably for everybody. Nicotine, depending on your age. The last 3 are generally considered to be illegal substances. Although cocaine is kind of interesting. Cocaine was not always illegal. Cocaine used to be in a lot of different kinds of medicines. For example, it used to be given a lot for like toothaches and things like that. But let's talk through some of the different stimulant medications. Again, caffeine is a legal substance, and caffeine is really cool because caffeine itself is sort of cheats. It's not exactly a direct stimulant. It cheats in that it's an indirect stimulant, and I'll tell you what I mean. It resembles a neurotransmitter that you have called adenosine. Now, adenosine is in this picture, it's little gray dots. It normally binds to these receptors, and when it binds, it makes you feel sleepy. But what caffeine does is caffeine comes in and binds to the same receptors and basically clogs them up so that it can't bind, so that the adenosine can no longer bind. And so basically it keeps you from feeling tired. So it's not that caffeine makes you feel awake, it's that caffeine prevents adenosine from making you feel tired. So see if you can remember back to part A of this lecture, part 1 of this lecture. What was it called when something prevented the functioning of a synapse. Let me go back and give you the two choices here. Anybody remember what that was called? No? Nobody got it? Was either an agonist or an antagonist? Well, in this case, this is an antagonist. In this case, caffeine is acting as an antagonist for adenosine. It is blocking or decreasing the functioning of the adenosine receptor. Does that make sense? And because it's blocking it, it's making you feel not tired, which is the effect that you're going for. Right? So what happens is that all this caffeine comes in, blocks the adenosine receptors, right? So then what happens is that you have all this kind of adenosine floating around going, oh, we don't know what to do. Our receptors are all blocked up. And so then the adrenal glands go, wait, we're kind of confused here. So then your adrenal glands secrete adrenaline, which is another stimulant. That's a hormone now. And so then you have kind of this double hit, right? Adenosine is blocked, so you don't feel tired. But then your body got confused, so it released adrenaline. So then you also feel alert and awake because of that as well. So caffeine produces sort of this double hit to your system that makes you feel awake. Now, it can actually be consumed in too much of an amount, which is the problem that I was running into, which is why my doctors got concerned. Adults should not be consuming more than about 400 milligrams of caffeine per day. I was definitely having way more than that, which is why I have significantly cut back. 400 milligrams is about the equivalent of about 4 cups of coffee. Well, I was already breaking that in the morning because I was having at least 8 cups of coffee in the morning, and then I was having energy drinks throughout the day. So I said, yeah, it was a very dangerous situation. I've gotten myself back into a safe range now, but just in case you were ever curious, I've given you this neat little kind of picture here. You can see some standard kinds of foods and drinks and how much caffeine is in them. A lot of people don't realize just how much caffeine is in regular chocolate, but there's a pretty good bit of caffeine in chocolate there. Another stimulant would be nicotine. Nicotine can also be legal depending on your age. It is similar in structure to acetylcholine. And it binds to nicotinic receptors. So we actually named the receptors after nicotine because we found the receptors after we had already discovered nicotine. So we named them nicotinic receptors. But over time, your brain will compensate for the fact that you've been consuming nicotine, again, usually in some kind of smoked form, although you can dip or something like that. But what your brain will do is actually pull out the number of adenosine receptors. And so this means you're probably going to need to be using more and more and more nicotine. So instead of a couple cigarettes, now you're going to probably have a half pack. Now you might have to have a whole pack, and that's that tolerance. So in this case of nicotine, this is how tolerance will occur, is that your brain is trying to compensate for the increased activity because you're giving yourself nicotine by pulling out the acetylcholine receptors. But again, you're probably just going to use more because of the tolerance because you still want the effect that you felt from the nicotine. What's also interesting, though, is that for a long time there was this debate of why is everybody getting cancer when they smoke? And then we decided, well, it's not the nicotine, it's all the other stuff that's in the cigarettes. And I don't want to at all downplay that. That is still absolutely true. There is a lot of just junk stuff that gets put into cigarettes. There's a lot of very toxic chemicals that are put into cigarettes. However, we have also recently discovered that nicotine itself might not be as good for you as we originally thought. Now, that being said, nicotine is not as terrible as some other things. Pure just nicotine. So like nicotine gum, for example, isn't as bad as like smoking a cigarette. There's definitely a lot of other bad stuff in the cigarettes. But nicotine itself has been shown to prevent apoptosis. Apoptosis is when your cells will purposefully die if there's something wrong with them. So if they've been formed wrong, if they have gotten damaged, your cells will purposely die off so they don't reproduce themselves incorrectly and lead to a situation where you get some kind of weird growth, like cancerous kind of growth. The problem is that nicotine stops that from happening. And so if you've got cells that are forming cancerous, they won't kill themselves off naturally, and it'll be a lot more likely that they'll grow into a cancerous mass. So what we think happens when somebody is smoking is that they sort of get this double hit. They get cells that get damaged from all the crap that's in cigarettes, but then the nicotine itself prevents those cells from naturally killing themselves off, and it makes them thousands of times more likely to develop all different kinds of cancers from smoking. So it's best just to avoid nicotine in general if you can at all help it. Now, some of the substances that are definitely illegal would be cocaine. Cocaine induces immediate euphoria, again, followed by this huge crash. Again, cocaine wasn't always illegal, though. It used to be given a lot for pain. Again, it was given in toothache drops. A form of it, called crack, can actually be smoked. Other forms of cocaine can be sniffed or injected. Again, probably the most common form that people know of is the powder form that people would kind of snort. Again, they're taking advantage of the fact that you've got those mucous membranes in your nose that you can snort and interact with. Cocaine enhances the activity of dopamine, so this would make it an agonist, and it blocks reuptake. So the dopamine not only comes out stronger into the synapse, but then it can't get taken back up as fast, and so it stays out into the synapse longer, and it binds over and over and over and over again, which is why you get that immediate rush that you feel, but also when it does finally get taken out of the body, you get that crash that you feel. This is just a kind of for fun slide. Most people don't have any idea how cocaine is made, and I just want to show you something else that's fun. So cocaine is typically made from the coca plant, not to be confused with the plant that is used to make chocolate, which is the cacao plant. The coca plant is an entirely different plant, but the leaves are soaked and mashed to form this kind of paste. And again, I've oversimplified that part a little bit, but go with it. Then you take that paste and you turn it into a powder by adding hydrochloric acid, and you get cocaine hydrochloride. On the street, that powder is typically diluted with other stuff because, again, every drug dealer wants to make a profit. And then to make crack, you take that powder, you dissolve that cocaine powder in water and baking soda and usually some kind of like ammonia, and then you basically boil that mixture until it forms a hard substance that can be broken into rocks. That's why they call it crack. Now, here's why I kind of went through that little thing with you. I told you earlier in the lecture that I used to work and give cocaine to rats, and I really wasn't kidding. And what's really interesting about cocaine is that I can order it, at least I used to be able to order it when I was working in the lab. I can just order a container of cocaine. I can literally just order it by the gram. A gram of cocaine, 5 grams of cocaine, 10 grams of cocaine. And it will come to me in this container, and it will be absolutely pure cocaine. It's literally cocaine hydrochloride, and it comes in powder form in a container to my lab, and I can give it to the rats. But again, people always are like, where do you get your cocaine from? And I'm like, I get it from the lab supply store. Here it is. It's not like I have a drug dealer that I keep on the side that I order it from for my rats. No, I literally order it from a company so that I know it's pure and I'm not going to be giving anything weird to my rats. Most of the stuff that we get is not actually made from the plant anymore. We get stuff that's synthetically made, again, so that we know it's pure. But I just thought you might find that interesting to see. And again, you would have to have a license to be able to purchase it. You have to have basically a grant number and an IRB number and all of these different things. And it's very highly regulated, which means you have to be able to account for every single little bit of the cocaine that is used and where it's gone. And again, it's not like you can just order cocaine for the lab and decide to throw a party at your house. No, absolutely none of that can absolutely happen. But I just thought you might find it interesting to know that, yeah, we would just call and order it up. And they'd be like, yep, we'll send it to you next week. No problem. All right, another stimulant is ecstasy. Ecstasy stands for a really, really long word there that I'm not even going to try to pronounce, but it is abbreviated MDMA, so you may have heard it abbreviated MDMA. Ecstasy is also a stimulant. Sometimes it's also categorized as a mild hallucinogen. It depends on the person, though. Some people don't necessarily get the hallucinogenic effects. Some people get more hallucinogenic effects than others. Some people get more stimulant effects than others. But MDMA causes a release of serotonin, basically this huge flood of serotonin into the brain. That's what people say feels so good to them. That's that mood elevating effect. But unfortunately, it also causes a severe mood crash afterwards because basically you have almost a deficit of serotonin after the dose of ecstasy. And it will damage your serotonin producing neurons. The question is just how much will it damage it? Will it damage it just a little bit? You probably won't even notice. Or will it damage it long term and significantly? And you will. People that have used ecstasy and had significant damage, and I worded it that way specifically because sometimes people can just use 1 or 2 hits and have the long-term damage. Sometimes people can use it a long time before they actually have the damage. There's no way yet that we understand how to predict who's going to get the damage when. We just know that it will damage it. It will damage your brain. That's all we know so far. Some people seem to be more susceptible than others. We don't seem to know the link yet. It's hard to say. But those that have had damage can have problems with memory, depressed mood, confusion, anxiety, paranoia. And just because I thought you might find this interesting, these are serotonin neurons. or so neurons that would release serotonin in the cerebral cortex. So this is what they should look like. So all the purple are all the different neurons. This is 2 weeks after somebody has used ecstasy. Look at how many neurons have died off or are not functioning correctly. And this is 7 years later. So some of the neurons have been able to regrow and start functioning again, but there's still a significant amount of damage. So this is what I mean by it will cause damage. It's just how much damage will it cause and how long-term will the effects be. One final stimulant drug is methamphetamine. Methamphetamine causes a cascading release of dopamine, and this is why the person feels the high or the rush that they feel. There's a lot of other names for methamphetamines, usually just abbreviated meth, but sometimes it's also called crystal or ice, crank, glass, speed. It's got a whole bunch of different names. I've given it to you, comes in a lot of different forms. There's a lot of long-term uses. It has a lot of negative consequences, again, not just for your brain, but for your entire body. It can lead to extreme weight loss. Small doses of methamphetamine are actually used in some of the medical weight loss programs. And again, I'm talking tiny doses of methamphetamines, nowhere near what people are using when they're using these as street drugs. But you can see now why if they are using them as street drugs, it would lead to extreme weight loss. These people would experience anxiety, paranoia, hallucinations. Sometimes these are permanent and long-term. Confusion, memory loss. It will actually make the person's skin less elastic, so it ages the person very quickly. It makes their skin look saggy and droopy. It can lead to permanent changes in brain structure and functioning. It leads to severe dental problems. This has been termed meth mouth from a lot of the acids and stuff, as well as from these people grinding their teeth because of the consequences of having that dopamine rush. Causes an increase in blood pressure. This strains the heart and can lead to heart attack and stroke. It causes this weird itching sensation kind of as a side effect, and it leads to people scratching themselves and leading to these skin sores that can get infected, and that can cause a whole host of secondary problems. So methamphetamine is just a really bad, yucky problem that you don't want to mess with. I said, unless it's in very small doses for very specific reasons given to you under a doctor's care. But another thing that I found interesting that I thought you might also find interesting is just how many uses there are for stimulant medications. Now, again, I told you about using small doses of amphetamines for weight loss, but amphetamines are actually also used for the treatment of ADD and ADHD. Now, not methamphetamine specifically, but some very similar chemical structured drugs. So methylphenidate, which is the generic for Ritalin, and another one that I'm not even going to try to pronounce, which is the generic for Adderall, are almost exactly similar to crystal meth or methamphetamine, right? If you look at them sort of chemically, they're almost identical. But two of them, Ritalin and Adderall, are actually used, again, in significantly smaller doses than most people would use methamphetamine for the common treatment of ADD and ADHD. But again, if those drugs are misused, so taken by someone that does not have ADD or ADHD, you're going to experience some of the same symptoms that you might if you took methamphetamine. So the euphoria, the exhilaration, the increased energy. Some people say that they like to use these as a study drug. And again, not that I don't want you studying, but again, this is not a healthy thing to be doing to your body. This can be a very dangerous thing, particularly for your heart, as well as some parts of your brain, if you're not diagnosed with ADD and you're not taking these medications under the care of a doctor, especially if you're also going to combine them with alcohol, because actually alcohol combines itself with these drugs and actually makes another chemical that's actually very dangerous for your body as well. Anyway, I just thought you might find that part interesting. The last group of drugs that we're going to talk about quickly are the hallucinogens. This is actually probably the most misrepresented group here that has actually had the most changes over time. We actually don't even really call them hallucinogens anymore. There are some drugs that are hallucinogens. Hallucinogens produce hallucinations. Your textbook might still define them as hallucinogens, that are drugs that distort perceptions and evoke sensory images, but really, that's not a correct term for that. Hallucinogens, as I said, produce hallucinations. All of this definition is actually what a psychedelic substance does. So most new textbooks are using now the correct word, so I'm hoping you will start using the correct word as well, which is a psychedelic substance. So psychedelic substance can produce hallucinations, but they are also the ones that can also distort perception, alter body awareness, Again, confused sensory images, things like that. So again, all hallucinogens are psychedelics. Some psychedelics can produce hallucinations. So hopefully that makes sense. But the two that I want to talk to you about that are technically LSD is a hallucinogen, but the better category name here would actually be psychedelics. So let's update this together. All right. Technically, this is the third group. These would be psychedelics. The first one is LSD. LSD is also probably better known as acid. It is the most powerful hallucinogenic that we know. Again, depending on, especially on the dose that you give, it's usually dissolved in the mouth, on the tongue. I've given you an example here where it was put on a little piece of paper. But probably the most well-known psychedelic is THC. THC, again, is the active ingredient that is in the hemp plant or that's in marijuana. And it can trigger a variety of effects. It's a very weird substance, THC is, because it's not exactly a depressant, although for some people it does make them feel very calm and relaxed. It does in some people actually produce mild hallucinations. Some people enjoy that, so again, that makes them feel relaxed. Other people say they have more like paranoia, so you get that bad trip feeling that you've heard some people talk about. But as of now, at least, it's still categorized as a psychedelic. My guess is as we learn more about what THC is doing, because we actually have discovered there are specific receptors for THC. They're called CB1 or cannabinoid receptors. There actually is a CB1 and a CB2 now. But the CB1 receptors we know can affect memory, cognition, mood, and the motor system, which is, again, why you feel some of those psychedelic effects, or at least the depressant type effects. That we may actually start, again, as I started this lecture with, we had these three main categories, but we started branching out and making some new ones. We may actually start putting THC into a slightly different category of its own. But for now, it's going to stick with the psychedelics. The action of cannabis results on all these different effects. Basically, it alters a lot of different neurotransmitters. It affects acetylcholine, glutamate, GABA. It affects a lot of different things, which is why a lot of different people have different experiences, why some people feel really, really calm, why some people feel moderately calm, why some people feel that paranoid. It just kind of depends. THC has also been shown to have a number of different health effects, again, because it is affecting so many different neurotransmitter systems, and it has a lot of other health effects in a lot of different places in the body. One of the most interesting ones that I am excited about is the work that they are doing with THC and pain, as well as the work they're doing with THC and appetite effects for people that have been going through chemotherapy and just, feeling awful after the chemotherapy, and they don't want to eat, and the chemotherapy is just making them feel awful. And as you know, it's sort of a joke, but THC and the use of marijuana gives you, quote unquote, the munchies. Well, they're taking advantage of that fact, and they're giving THC to patients that don't have an appetite following some of these medical procedures in hoping that they will increase their desire to eat and take care of themselves and actually want food so that they can heal faster and heal better. And then also with pain, THC has been shown, we don't quite understand it yet, but it's been shown to actually produce some interesting effects as far as lessening pain in people with chronic pain. And it doesn't seem to be nearly as addictive as some of the other pain substances that we were talking about that are actually true depressants. So the opiates, for example, that we were talking about. So there's a lot of new and exciting research that's out there with THC. THC also has a really bad, I'm just going to put it out there, racist history as far as drug laws and things go. But that's a whole different subject for a whole different day. I actually teach a class, hopefully I'll be teaching it again next summer, called Addiction, Drugs and Addiction. It's a 3001 class. If you're interested in this stuff, we'll go into a lot more detail. You should come take that with me next summer. One last thing though about LSD. I wanted to give you a little bit more information about that. LSD, the reason it produces the hallucinations and something called synesthesia, which is basically where all your senses get mixed up and you can like see sounds or you can hear colors, is because you get this huge weird flood of serotonin in the brain. Right, so serotonin is the main drug that is released. LSD is even called a serotonergic hallucinogen. And so if you kind of look at it, you can see this is what a person's brain that's lit up should normally sort of look like. And the orange and the red means an area of the brain is active. Right? But look at what the brain is active like when a person is using LSD. It's like super activated, right? And so this is why basically you have so many sensory areas of the brain that are activated while the person is high on LSD. This is why they get those weird sensory basically mix-ups. And they can do things like hear a color, right? They see red, they hear a particular sound. They see purple and they hear a different sound. Again, because you've got the sound regions and the sight regions all going off at the same time because of this crazy overactivation. And your brain doesn't know anything else to do except for to try to put it together and make it make sense. And so what you experience consciously, this is that sensation versus perception thing. The perception that you experience is a mixing up of your sensory systems. And some people say they really like that sensation, and other people say they really think that's weird and they don't like it. It just depends on the person. Again, it can be dangerous, although not as dangerous as some other things. But again, in general, I recommend that you not necessarily use illegal substances, mostly just because we don't know a lot about the long-term effects of most of these, with the exception of maybe marijuana, although again, there's still a lot we don't know there. But definitely don't use something that's illegal. That's a whole different subject. And again, if you do like this topic and you think this is interesting, first of all, now you understand why I fell in love with this topic and went and studied this in graduate school. And again, I just squished into the shortest lecture possible I could what I just studied in 5+ years in graduate school and then since then. But nonetheless, hopefully you found this interesting and you got a little bit out of it. And I will talk to you guys soon. Bye.